Professor Bialis here. Today we're going to talk about section 2.5, which is formulas and problem solving. Again, problem solving is word problems. Formulas, though, is when you have a predetermined equation that relates certain quantities, certain values. Okay? So it's not something that we just have to translate off the top of our head. It's something that's already predetermined. The difficulty is we need to come to the table having that relationship all ready to go. Okay, the formulas that we're going to be dealing with here are nothing too crazy. Anything that we use in an example, I do want you to have down because they are very commonly used formulas. But if you need to have something that you haven't seen in a while memorized, then write it on a piece of paper and read it, read it, read it. Okay, that's really the easiest way to have anything memorized. Just compile it in one spot, and if you have 30 seconds or a minute here and there, just take it out of your pocket, read through it a few times. Okay, so I want to start out with practice one. Again, practice problems are after the examples in the text. The first practice problem is on page 118. So again, this is section 2.5. We're dealing with formulas and problem solving. Practice one. And that reads, the Stromboli volcano in Italy began erupting in 2002 and continues to be active after a dormant period of over 17 years. In 2007, a volcanologist measured the lava flow to be moving at 5 meters per second. If the path of the lava flows to the sea is 580 meters long, how long does it take the lava to reach the sea? Okay, that's a lot of information. However, what are we talking about? That's all I care about right now. We are talking about lava from a volcano flowing down to the sea. End of story. Okay? Now I read it again and start pulling the important information out of it. So again, it says the Stromboli volcano in Italy began erupting in 2002 and continues to be active after a dormant period of over 17 years. We're talking about a volcano. I don't need to read that again. In 2007, a volcanologist measured the lava flow to be moving at 5 meters per second. So let's write that down. We've got 5 meters per second. Okay. Next it says that if the path of lava flows to the sea is 580 meters long, how long does it take the lava to reach the sea? So we know that we need to cover 580 meters. Now what would that represent? Meters per second is a rate, or you could call it a speed. This, just pure meters, that is a distance that we need to cover. Now when they say how long does it take, the long that they're mentioning here and that they're trying to find is a time. I don't know how long that's going to take. These are the 3 pieces of information that are either given to us or asked of us. Now, how do these 3 relate? Now, this is where the formula comes in. The formula is nice and short, and it's distance equals rate times time. There's your formula. Okay? So, we list what we have, just like we did in the previous section. But now here, we didn't need to translate that. We just needed to know that these things go together in this way. Now, we plug and chug. Distance is 580. The rate is 5. Whoops. And then the time, I don't know. And then we have a very simple equation to solve. Divide by 5. 580 divided by 5 is 116. Okay? They asked how long. That's your time. You're good to go. Now, be careful here because it's 116 what? In this case, we're talking seconds. How do I know it's seconds? Because we had seconds in this other part of the problem. So use the other labels to determine what you should be labeling your answer at the end of the problem. And there we go. Simple as that. Again, the tricky part is knowing this. Seeing these components and knowing they come together in that way. Now, practice 2. Practice 2 can be found on page 119. And it reads, Evelyn Grick fenced in part of her backyard for a dog run. The dog run was 40 feet in length and used 98 feet of fencing. Find the width of the dog run. Okay, so we have someone fencing in an area of their yard to let their dog in. That's it. Okay, now how are they fencing this in? It says they have part of their backyard they're fencing in for a dog run. We don't need to read that again. The dog run was 40 feet in length and used 98 feet of fencing. Find the width. Whenever they mention a length and a width, we're talking about a rectangle. Okay, so what we have is an area of the yard fenced in like so. Every rectangle has a length and a width. Now, what do they say to us? They tell us that the length of the dog run is 40 feet. So I know that this length is clearly given as 40 feet. They don't say anything about the width. What else they tell us is that that 98 feet of fencing was used. Now, fencing goes around an area, correct? Now, mathematically, how do we measure going around something? That's where we have a perimeter measured for that fencing. Okay, so they didn't use that term. We had to know how that translates into a mathematical idea. Okay, so we have a length of 40 feet. We have a perimeter of 98. The width, they just say, find it. Okay, so I'm going to leave that as a W. Okay, I like to put the length and width inside so I know which is which, but then the parts that I actually use, I put on the outside. Okay, if you have a different way of organizing that, by all means go ahead and do so. Okay, now, how can we relate a perimeter, a length, and a width? Well, we have a formula for that. And that formula is perimeter equals 2 times the length plus 2 times the width. You could also say length plus width plus width. This is a little bit more of a concise way of doing it. Okay, now let's fill in what we know. I know the perimeter is 98. I know the length is 40. Whoops. And the width, I don't know. So we now have an equation we can solve. Up here, we have 3 unknowns. We can't do anything with that. But now we only have 1 unknown that we can fill in. So I'm going to go ahead and solve this. Now, usually the first step is to distribute. All distribution is a fancy way of multiplying. So I've got 98 equals 80 plus 2w. Multiply first. Then subtract the 80. And then divide by 2. And there's your width. Okay, now make sure you answer the question. It specifically said find the width. We did that, we're good to go. We have 9 feet. Okay, now if you're following in the book, which I hope you are, I'm actually going to skip to practice 4. I like holding off on practice 3 until right before the next phase of this section. It's a nice segue. So let's go into practice 4. Practice 4 is found on page 121. And it reads, the new street signs along Route 114 have a length that is 3 inches more than 5 times the width. Find the dimensions of the signs if the perimeter of the signs is 66 inches. Okay, now the street signs they're talking about are those typical green rectangular signs that we have on the street, okay, telling us that we're on Elm Street or Smith Street or anything like that. Now, again, let's read through it again. It says the new street signs along Route 114 have a length that is 3 inches more than 5 times the width. When they mention length and width, remember, we're talking about those rectangles. So even if you're thinking of a different sign, we have a rectangle that we're dealing with. Okay, so let me get this started. I have my rectangle, I have a length, I have a width. Okay, now let's see what kind of detail they give us. The new street signs have a length that is 3 inches more than 5 times the width. Now again, which did they say nothing about? They mentioned length and width, but they didn't describe the width. So I'm going to leave that as a W. Okay, that's my variable now. Then it says again that the length is 3 inches more than 5 times the width. 3 more than 5 times the width. 3 more than 5 times the width. 5 times that width, 3 more than that. And there's my translation. Okay. Now, they give you one other piece of information there, though. It says the perimeter of the signs is 66 inches. So they come out and say perimeter is 66. And we've got this. So we had length, width, we had perimeter. Again, same formula we just used. Perimeter is twice the length plus twice the width. If you ever use a formula, and this goes for the rest of this course and your next course and the course after that, if you use a formula, write it down. Okay, the more you write it down, the more you're going to have it memorized, and you're not going to have to look it up every single time. So we have 3 unknowns there. Let's plug in what we have. Okay, perimeter is 66. Now the length, the previous problem just gave us the length. Here we have a new expression to plug in, which is useful because now we're only going to have one variable to deal with. So the length is 5w plus 3, and the width is still just the width. Okay? And now we have an equation to solve. Before I jump into solving this, I would just kind of take a tally of what we did, make sure that everything was written down correctly before you go through all that process of solving. So I start by distributing. I then combine like terms. I then subtract the 6. I then divide by 12. And 60 divided by 12 is 5. Now, let's make sure we answer the question, though. Okay, it says find the dimensions. So we need length and width. The width is 5 inches, but the length is this. 5 times 5 is 25, plus 3 is 28 inches. And there are your dimensions of the street sign. Okay? Bottom line is, don't read it once and expect all of this to just fly on your paper. I had to read that problem 4 or 5 times. And maybe not the entire thing, but pieces of it. Take it one sentence at a time, and when they give you an introductory sentence like, hey, we're talking about street signs, read it once and then cross it out. Don't read it again. And then that problem that you see as this long thing really starts to shrink down to the bare necessities. Okay? Now, let's do one more problem like this, and then we're going to segue into another aspect of this section. Let's go back to practice 3, which is on page 120. Practice 3 states, the average minimum temperature for July in Sydney, Australia is 8 degrees Celsius. Find the equivalent temperature in degrees Fahrenheit. Now there's a lot of detail there, a lot of description of the location, the time of year, and all that. All we really care about is we are taking 8 degrees Celsius and we are converting it to degrees Fahrenheit. That's really all they had to say. Okay? Now, there is a formula for this, and this is the formula that I tend to see people know the least. Okay? But after you use it a few times, it should come back to you. The formula is F equals 9/5 C plus 32. Okay? Now, all we have to do here, first of all, guys, this 32, if we can put some meaning behind it, it is easier to remember. What's the freezing point of water in Celsius? 0. What's the freezing point of water in Fahrenheit? 32. That kind of equalizes those two different units. The 9/5 then, why is that there? Because if you look at a thermometer, if you look at the tick marks for Fahrenheit and the tick marks for Celsius, the spacing in between them is a little different. And that's where this type of thing is coming in. Okay? So here's your formula. We want to go to degrees Fahrenheit, piece of cake. And that is just a straight plug and chug. And then what you should get out of that is 46.4 degrees Fahrenheit. That's all. Okay? If you want to do this by hand, fine. If you want to pick up a calculator, fine. Just do what's right for you. Okay? Now, this brings me to the next portion of this section, where we actually just work with formulas and manipulate the formulas themselves. Now, this was a very easy formula, and it was set up to translate Celsius to Fahrenheit. But what if I was going the other way? What if I wanted to know the equivalent Celsius temperature for 83 degrees Fahrenheit, for instance? Then I would have something like this. If it was 83 degrees Fahrenheit, I would have that. And then I would have to bring the 32, I would have to solve the equation, okay? Which is not a big deal unless I ask you to translate 50 of these Fahrenheit temperatures. Then you're solving that same equation again and again and again and again. And that right there is a waste of time. Okay, so what we can do is solve the formula once and create a new formula. Any of you who have taken a physics class probably remember for each chapter you had a huge list of formulas. Now, there are going to be a lot of formulas in a physics class regardless, but if you know how to manipulate it, sometimes you can take 10 formulas and whittle it down to 5 because they're just variations of each other. So what I mean is this. This is a Fahrenheit formula because the Fahrenheit is solved for. If I want a Celsius formula, I take this and I solve for C. Get the C alone. I use the same 6 steps that we had back in equation solving, but now there's not as much calculation to be had. So what I'm going to do here, I could move the 32, or I could multiply through and clear that fraction. It's up to you. Okay. What I typically see in textbooks is taking that 32 over first. Okay. I'm trying to get C alone. I undo plus 32. So I have F minus 32. I can't carry that out. Equals that. Now watch this next step. I could multiply by 5 and then divide by 9. Or in one swoop, I can multiply by the reciprocal. I multiply this side and this side by the reciprocal. And we got that. If you had this distributed out, that's not the end of the world. Depending on the textbook and the application, sometimes they distribute, sometimes they don't. They're both perfectly acceptable. So what we did was we took this formula that was already given to us and established, and now we have a new formula that's ready to go and solve for Celsius. And in that one process, I solved for C once. I don't have to do it again. I can plug in the F and calculate. Plug in the F, calculate again and again. Okay, so I create something new off of something that is old. Okay, let's look at a few more examples of this. Let's say I have a basic volume formula, which is length times width times height. That's a nice formula to get the volume. But let's say I know the volume and I want to figure out the width. I'm going to solve for W. I want to get W by itself. Now this one's a little tricky because notice this is one big product, length times width times height. You undo multiplication with division. Do it all at once. I'm going to divide both sides by length times height. Canceling, canceling, and I have the W alone like I wanted. And I have volume over length times height. And that's all there is to it. Okay, let's do one more. This type of thing we are going to see a lot in chapter 3 when we're graphing linear equations. Okay, and I want to solve for y. Okay, so to get y by itself, I'm going to subtract 2x to get 5y equals, now again, these are not like terms. That's okay. I'm not going to pull them together and actually evaluate. I'm just going to give a new expression. 7 minus 2x. That's all I have to do. Then I divide by 5. And there we go. And there is your answer. Okay? So there's two components to this section. There's the application, solving word problems, and then there's manipulating formulas. This is going to be very, very crucial when we get into graphing of linear equations and beyond that, but especially with the graphing of linear equations. Okay? So, as always, work hard. Let me know if you have any questions, and I'll see you next time.